right, so here we go with the key for 5.3. So let's see here. We're talking about finding the cursor. There we go. All right, so it says Vx. Looks like we have a bunch of medians here, so that would make this the centroid. Just from a glance, right? We have vertex to midpoint, vertex, midpoint. Okay, centroid. And so what we know about that is that the centroid is splitting each one into two pieces, a big piece, small piece. Big piece is double the small piece. But let's see what we got. So it says Vx is 204. So Vx, so the whole thing is 204, right? This entire thing here. Totally missed. All right, and then Rw is 104. Okay, so let's see what it's asking me for. It's asking me for VW. So the easiest way to do this is to just sort of take this and we're going to split it three ways. In other words, like if this is x, this is 2x. So the whole thing is 3x. So I just split this whole thing three ways. And that's because, again, sort of the nature of the median is it does split it. And so we get 68. All right, so this is 68, right? And then we double it to get the other one, to get the other part, the larger part, which is 136. So in other words, we sort of split this median up into two parts, right? 68 and 136. And you know that is double that. Sorry, the one on the right is double the one on the left here, and they both add to 204. So that's what we're looking for. Anyway, so VW is 136. WX, which we already found, was 68. RY, so if the big piece is 104, that means the small part is half of it, or 52. So RY is the whole thing, which is going to be 156. And then WY, we already know, is 52. So the main thing here is that if you have medians, in other words, you have a centroid, you always have sort of a large part and a small part. So if you're given the small part, you can double it to find the large part, add them up to find the whole thing. If you're given the whole thing, it's probably the toughest part. So if you're given the whole thing, right? So let's say the whole thing is 30. What you can do is you can split it you can divide it by 3 to get the small part. So we divide it by 3 is 10, get the small part. We double it to get the large part. Okay, so no matter which one you're given, you can sort of find them all. And again, that was just an example that obviously has nothing to do with that problem. All right, so we're going to keep on doing that for a while now. So we have PA is 2.9, and we have HC, the whole thing is 10.8. Okay, so find each length. So I'll just find the ones that I can and see if they work. So this is 2.9, right? Then I double it sort of to 5.8. And then the whole thing would be sort of 5.8 plus the 2.9, which is just going to be 8.7. So the whole thing, AJ, is just going to be 8.7. In this case, the whole thing is 10.8. So I divide that by 3, and I can get the small piece, which is 3.6. And I can get the large piece by doubling it to get 7.2. Let's see if that's what it's asking me for. Yep, PC is 3.6. I already have that. HP is going to be 7.2. Got that. JA is the whole thing, AJ is what I put over here, which is 8.7. And then JP is going to be 5.8. So again, if you get what you can, and then everything else becomes a little easier. All right, what I'll do is I'll mark everything I can in this diagram first. This is 6.5, so is this. If this is 8, okay, that means this has to be 4, and the whole thing is 12, so I'm just going to write down here that GL equals 12. And then it asked me for GL. Oh, good, that's nice. PL is 4, that's good. HL is 5, right? It actually could have done that based on that. So HL is 5. GJ. So this is where it gets a little tricky. But the main thing here is that it really comes down to this line right here. This line is basically splitting this whole triangle into two sort of congruent triangles. In other words, it's kind of saying well, splitting it into two congruent triangles. And again, I know they're congruent because this blue line is congruent. We have a side, angle, side, right? That's also side. So in other words, this whole side here, HG, is going to be the same thing as GJ. In other words, the whole triangle is going to be congruent. So this whole thing is 6.5 and 6.5 is 13. So this whole thing is 13. So that's what GJ has to be. And then it asked me for the perimeter. Well, that's just going to be 13 plus 13 plus 10, right? 36. And the area, so we know the area is going to be, and again, I could just write that's 13 plus 10. Using my perimeter. My area we know is 1/2 base times height. And so in this case, the only one that can be the base and the height, remember the height has to be perpendicular. So the height in this case is this one right here is 12. And to its base, which I know is over here, HJ, which is 10. So 1/2 of 120 is 60. I don't have any units, but it would be, square units. Okay. So again, the main thing there was sort of seeing that this happened to be sort of an isosceles triangle. All right. So in this case, again, we know that this is a median, so this has to be our centroid. Again, it goes from the midpoint to the opposite vertex. Same thing over here. Okay, so what we can do is we can write an equation. And so in this case, we sort of, I'm going to have to deal with this one first, because this one I have 4n minus 26, but I don't know this other piece, so I can't write an equation. In this case, what I could say is a couple things. I could say, well, 2 times the small piece equals the big piece. And that's probably what I'm going to do. I'm just going to say, you know what, 2 times 27. If I multiply 27 by 2, that will equal 2n plus 17. Right, and so we get 54 equals 2n plus 17. I get 2n equals 37. Too slow. Okay. And so again, the main thing there is that the main thing there is that I saw that, again, if this is 27, this has to be 54. Again, just by multiplying it by 2. And so, yeah, 2n plus 17 and 54, they're the same thing. So you're going to jump to this one as well, and that's okay. And that gives me basically n is 18.5, which is a perfectly cool number. So now that n is 18.5, I can actually plug that back in and multiply it by 2 and then add 17 to get 54. Actually, I already knew that. Never mind. I already got that. All right. But what this does is it gives me this other one, right? So, so PZ I know is 54. I already knew that. PX is going to be 54 and 27 together. So 81. QZ, okay, so QZ I can find just by plugging in what I know. In other words, 4 times 18.5 minus 26. Which gives me 48. So that means this piece right here is 48, which means the small piece has to be half of it, or 24. So YZ is 24, QZ is 48. But the main thing is it sort of all stems from finding this equation first. Okay? So tell us, always, sometimes, never. A median of a triangle bisects one of the angles. That could be sometimes. Again, that would be if it was equilateral or isosceles, and coming from the vertex angle. If one altitude of a triangle is in the triangle's exterior, then a second altitude is also in the triangle's exterior. And yeah, that's true, because again, if one's in the exterior, that means it's sort of an obtuse triangle. And so if you have one out here, then the other one is also going to have to be out there. Right, part of sort of this triangle I should have, right? So that would be always. The centroid of a triangle lies in its exterior. That is not true. That is never true. The centroid is always in the interior of the triangle. In an isosceles triangle, the altitude and median from the vertex angle are the same line as the bisector of the vertex angle. That actually is always true. Right? In other words, if I'm looking at an isosceles triangle and it says the altitude, right, and median from the vertex angle, so it's an altitude and it's a median, are the same as the bisector of the vertex angle. That's true. Again, basically the main thing is you can always make it so, oh, look, we can, there's a lot of angles we know based on other things, but essentially we can say that these triangles are the same, which means these angles are going to have to be the same as well. So everything comes the same when you do from the vertex angle. Which statement is not necessarily true if these are all medians? In other words, that's the centroid. QP is 2/3 of QT. That is true. And the large part is 2/3 of the whole thing. That's true. RT is going to be equal to ST. That is true because, again, if this is a median, we know that these are going to be congruent. RP is going to be 2PB. That is actually true. So, again, we know it's this, but let's check out why. Again, what that says is that it's the big part is always going to be twice the small part, and that actually is true. QT is going to be equal to SW. So that we don't know the medians are congruent, right? You never know the medians are congruent to each other. You just know that the centroid splits the medians into sort of parts. All right, so suppose the orthocenter of a triangle lies outside the triangle. Which points of concurrency are inside the triangle? Okay, so in other words, what this is saying is if the orthocenter is laying outside, then we know it must be an obtuse triangle, right? That's what the first part says. So in an obtuse triangle, the incenter will be always on the inside. The circumcenter will not be, but the centroid will be. So 1 and 3. Which is here, G. In the diagram, which the following correctly describes LN. So LN, what do we know about LN? LN is here. It is perpendicular to the side, but it doesn't go to the opposite vertex, right? So if it doesn't go to the opposite vertex, but it does go through the midpoint, right? Because this is a midpoint, so it's perpendicular and it bisects that. So it's a perpendicular bisector. Not so bad. Okay, and then you could say HK would be an angle bisector, JM would be a median, all that good stuff. All right, cool. See you in the next one. Unless we're not done. Totally not done. I was lying the whole time. All right, here we go. All right, so we know that this is a centroid. We know that, so that means we know that these are medians. So I'm going to mark them all as the midpoints because, again, that's what a median does. It goes from it goes to the midpoint to the opposite vertex, and so we know that those must be midpoints. Okay. And that thus the centroid is sort of cutting these things into 2/3, 1/3, or 1 is double than the other. So if this is 4, then this has to be 2. If this is 6, that's 6. And again, they probably give me more. They give me TV. The whole thing is 9. So if TV is 9, I can split that into 3 and get 3. So that's the small part. It's going to be here is 3. So that's going to be 6 because I just doubled it. So let's see what we got. RV. RV, I already know, is 6. SU is 2. RU is going to be 6. RW is going to be 12. TS is going to be 6. SV is going to be 3. See, once you mark everything and write everything then it becomes pretty easy just to sort of figure out stuff. All right, so we know that this is the diagram here. It says that FG is x plus 8. And this is 6x minus 4. And so what do I know? I know that that twice this should equal this. In other words, 2 times the small piece equals the big piece. And so we can say 2 times the small piece, which is x plus 8, equals the big piece, which is 6x minus 4. And we can find x in this case. So we get 2x plus 16 equals 6x minus 4. And so we get 4x equals 20. And so we get x equals 5. All right, and now we come back here. It says CG is 3y plus 7, and CE, so the whole thing is 6y. So this whole thing is 6y. And so what I'd say is, okay, there's a couple ways to sort of do this, but remember that the 2/3 of this will be this. So 2/3 of the whole median will be the big piece. Okay. And so, I mean, you could break this down and say, if you do this over 2 is going to be this piece, and 3 times this piece will be that. And so that is also another way. In other words, this is just going to be, like 3y plus 7 all over 2. And if I multiply this bit by 3, it should equal this. Okay. I mean, so that's okay to do, but I think the easiest way is just to say, 2/3 of 6y is going to be 3y plus 7. And 2/3 of 6y is pretty easy. It's just 4y. So that's why that might be the easiest way to do it. But again, the other way is also fine. Again, if you did 3 times 3y plus 7 over 2, that is okay. You do divide by 3 to get 2y equals 3y plus 7 over 2. And then you multiply by 2 to get 4y equals 3y plus 7. But if you notice, we're in the same spot. So I'm just going to finish it on this side over here. So we get y equals 7. Oops, that looks like an x. Y equals 7. All right, and now we're done. See you in the next one.